The existence of alien life in the universe has been a big question for science. So far, we have no solid evidence about the existence of other life outside our Earth. But according to our best theories, which say that the universe is full of alien life, the chances of us being alone in the universe are almost zero. It is only our lack of knowledge about the universe that has kept us from contacting other life forms in the universe.
What is the mathematical probability that there is life out there in the universe? And if you calculate in billions of stars, in billions of galaxies, that there's replicated what I just said, another stony planet. The answer was, what's the likelihood? At least 1 trillion. That's from our scientist.
Furthermore, many scientists believe that our universe not only hosts other life forms, but is also filled with advanced alien civilization. Many intelligent civilizations exist beyond our solar system. Well, recently scientists found in a research that the expansion of our universe can be a big threat to these advanced civilizations. This amazing study has also revealed that advanced civilizations are doing something amazing to avoid this danger. When it comes to existential threats facing humanity, there are different levels of urgency. Diseases, nuclear conflict, resource depletion, and potential asteroid impacts all have widely researched potential for harm to society in our current era. These threats naturally create a sense of apprehension in the collective consciousness. But one threat that is near the bottom of the list is the accelerating expansion of the universe. Indeed, it hasn't been considered a clear threat at all until now. Dan Hooper, a particle physicist at the Fermi National Accelerator Laboratory in Batavia, recently revealed that we are unable to study, communicate, or influence things beyond the cosmic horizon, which is the maximum distance that light can travel to us within the age of the universe. But the cosmic horizon is undergoing a shift. Dan Hooper has figured out how this will impact our cosmic neighborhood, known to astronomers as the local group. This encompasses roughly 50 nearby galaxies connected by gravity to the Milky Way. They're on a trajectory to eventually collide over the course of the next trillion years, ultimately forming a unified supergalaxy. Consequently, the local group will be humanity's home for the foreseeable future. Over billions of years, we might even colonize it, hopping from one star system to another and exploiting each sun's energy along the way. However, the accelerating expansion of the universe is sending galaxies over the horizon at a rate that is increasing. As a result, over the next approximately 100 billion years, all stars residing beyond the local group will fall beyond the cosmic horizon and become not only unobservable, but entirely inaccessible. And recently, scientists revealed that the disappearance of galaxies beyond the cosmic horizon could be a major threat to advanced civilization, because it limits the number of new stars that are available to exploit. Dan Hooper says, if there are any advanced civilization, they will be in serious trouble due to lack of available energy resources. So the question that Hooper investigates is whether there is anything an advanced civilization can do to mitigate the effects of this accelerating expansion. Surprisingly, it turns out there is. Every living creature on Earth relies on natural resources for energy, including us humans. However, our unique gift of intelligence allows us to extract energy from nature more efficiently than any other species on our planet. In a similar vein, civilizations in the universe that are far more advanced than us might possess even more sophisticated technologies for harnessing energy from the resources around them. Advanced civilizations might harness energy through processes like antimatter reactions. Antimatter is a type of matter composed of antiparticles, which have properties opposite to those of regular particles. When antimatter comes into contact with regular matter, both annihilate, releasing an enormous amount of energy. However, producing and storing antimatter is currently beyond our technological capabilities. Other methods might involve tapping into the fundamental forces of the universe. For instance, civilizations could harness the power of gravity through techniques like gravitational slingshots or by extracting energy from black holes. But the most likely method, according to scientists, is the use of Dyson spheres, hypothetical megastructures that surround the entire star. Back in the 1960s, the legendary physicist Freeman Dyson speculated that advanced civilizations would attempt to gather as much energy from their suns as possible. He suggested that the obvious way to do this was to entirely encircle each star with a sphere that captures all the light produced. This energy can then be exploited and the waste heat radiated into space as sub-millimeter waves or infrared light. Well, for decades, astronomers have searched for the specific radiation signature that these Dyson spheres would produce, but until now, we haven't found any kind of technical signature. So, does this mean that the Dyson sphere idea is wrong? Or are our technologies not advanced enough to detect such things? Dan Hopper recently claimed that since the accelerated expansion of our universe is sending nearby stars beyond the cosmic horizon, and this would be a threat to advanced civilizations, therefore, advanced civilization would have used a Dyson sphere to solve this problem. Hooper's idea is that an advanced civilization could build a sphere that emits waste radiation in a specific direction. This radiation would accelerate the sphere and the star it contains in the opposite direction. Over time, an advanced civilization could use this technique to gather stars as a source of energy and thereby keep them inside the cosmic horizon as the universe expands. An important question is, what kind of stars would be suitable for this endeavor? Hooper says that large stars tend to be older and so would run out of juice while being maneuvered. On the other hand, very small stars produce less energy and cannot accelerate quickly. These stars could not be maneuvered quickly enough to stay inside the horizon. Hooper's conclusion is that stars of about the same mass as the Sun would be best suited to this kind of galactic transport. He says that concentrating stars in this way would increase the amount of energy available to civilizations by a factor of several thousand, and that could keep them going much longer than would otherwise be possible. There is a measurable prediction from Hooper's work. If advanced civilizations have already begun this star-gathering process, it should be observable to astronomers. Such a civilization could appear as a region up to tens of megaparsecs in radius, in which most or all of the stars lighter than are surrounded by Dyson spheres. No doubt, astronomers will eagerly search for such a signature. However, Hooper's work relies on two assumptions. The first is that an advanced civilization will attempt to maximize its energy consumption. That's by no means certain. Perhaps such civilizations will learn how to make do with what they've got. The second assumption is that cosmologists are correct in thinking the expansion of the universe is accelerating. Once again, this is no slam dunk. A lot of scientists feel uneasy about the notion that the universe will keep on expand forever, and they're even more uneasy about the thought that this expansion is accelerating. One major worry is that this rapid expansion goes against the fundamental principle of conservation of energy, a key concept in modern physics. Advanced civilizations are more likely to have solved this conundrum, so the absence of Dyson spheres in the groups Hooper imagines may just be evidence that our cosmologists have got it wrong. Well, at the end, the notion of advanced civilizations guiding the expansion of our universe remains firmly in the realm of speculation. It serves as a powerful reminder of the boundless mysteries that await our exploration. As our understanding of the cosmos continues to evolve, it is essential to keep an open mind and consider the possibility that the universe may hold secrets beyond our current comprehension.